Alright, hello math fans. Today we are going to be working on sine, sum, and difference. Now we had a big derivation for cosine, sum, and difference. And we could do a derivation similar to that, but we don't need to. And the only reason we don't need to is because we can say sine of theta, if you guys remember this, is equal to cosine of 90 minus theta. And why is that true? What are sine and cosine? Do you guys remember? They are cofunctions. Remember that? So in other words, if I said the sine of 30 degrees, that's equal to the cosine of 90 minus 30 degrees, or cosine of 60 degrees. And if you remember, sine of 30 degrees is 1/2, cosine of 60 degrees is also 1/2. Okay, so sine and cosine are cofunctions, so this is actually really important right here. Okay, with that in mind, now we can say sine of A plus B is equal to the cosine of 90 minus parentheses A plus B. Alright, that's important because now we can actually use cosine sum and difference to calculate this out. Well, let's kind of simplify this a little bit. And let's rewrite this as cosine of 90 minus A minus B. So it's really cosine difference. That's what we're going to use. So we're going to say cosine difference. So cosine, I can rewrite this as cosine of 90 minus A cosine of B, because this is basically my first term and this is my second term. So remember, it's cosine A, cosine B, and then the opposite sign, so it's going to be plus sine A sine B, or sine 90 minus A sine of B. So that is using cosine difference to write that out, which again, the sine of A plus B is equal to, these two are equal. Very important. So now I can actually simplify this a little bit, and I can write this. We already know, again, let's make a little note on this top right hand side here, that the sine of theta equals cosine of 90 minus theta. So I can substitute 90, instead of saying cosine of 90 minus A, I can say that's sine of A, cosine of B, and sine of 90 minus A is the same thing as cosine of A, so it's plus cosine of A sine of B. And there we have it. This is sum for sine. And as we did with cosine, I'm going to do sine of A minus B by just substituting a negative B in for B. So I can actually write this as sine of A plus a negative B. And then I can do a direct substitution into the equation we already just created, this guy right here. So that's going to be sine of A cosine of negative B plus cosine of A sine of negative B. And then I can simplify this. Remember, Cos is pos. So that just becomes sine of A cosine of B. And sine of negative B, remember when it's sine of a negative angle, that's negative sine of that angle. So it's minus cosine of A sine of B. That is sine difference. Two important formulas that you need to know. Okay, so let's use these formulas in a couple calculations. So let's start out with sine of 15 degrees. Really very much the same as cosine of 15 degrees. You kind of just need to find a combination that gives you 15 degrees. So we have sine of, and we'll just use 45 minus 30. And then we just substitute in. This is your A, that's your B, and its difference. So it's going to be sine of 45 cosine of 30. And the way you remember also sine, the sign is the same for sine. So if it's difference, it's going to be a negative. That's very important. I did mention that in the previous screen. But that's one way of remembering that. Cosine is a different sign. It's opposite sign. So cosine of A plus B is got a minus sign between them. And sine of A plus B has a positive sign. So it's the same sign. So it's sine 45 cosine 30 minus cosine 45 sine of 30. Okay, remember the sign goes first. So sine of 45, sine of 45. Okay, and then we just need to simplify it. So we have square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45, root of 2 over 2. And sine of 30 is 1/2. And remember, the denominator is always going to be the same. If the denominators do not wind up the same, you've got to go back because you picked the wrong, you just didn't do something correctly. So square root of 2 times square root of 3 is square root of 6 over 4 minus square root of 2 over 4. So your final answer is square root of 6 minus square root of 2 over 4. Pretty straightforward. So let's try a nice friendly one here. Sine of 5 pi over 12. So just as again I taught you with cosine, you have to come up with combinations of pi's over 12 that get you 5 pi over 12. So as I said before, you might want to write some things out here like pi over 3, pi over 4, and pi over 6. And pi over 3 is 4 pi over 12. Pi over 4 is 3 pi over 12. And pi over 6 is 2 pi over 12. So 5 pi over 12 is going to be a combination of pi over 4 plus pi over 6. So that's sine of pi over 4 plus pi over 6. That gives me 5 pi over 12. And then I just use our sum and difference. So that's equal to sine of pi over 4 cosine of pi over 6. And because it's plus here. And then it's going to be cosine of pi over 4 and sine of pi over 6. So we figure out these values. We get square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2 plus square root of 2 over 2 and 1/2. So that's equal to square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 over 4. That's my answer for that. So that's pretty easy. Notice these are all angles that are acute angles. Okay, so again, just like before, what happens if you have something that's not an acute angle? Very simple. So let's do a nice little example here. Okay, so we're going to do sine of negative 105 degrees. Brutal. Okay, well, even dealing with negative 105, we don't want to deal with any negative angles, so let's just get rid of that negative right away. And you guys remember, that's the same thing as negative sine of 105 degrees. Much easier. Now we're dealing with 105 degrees. It's still not an acute angle, but the next thing we're going to do is we're going to find our reference angle. And you know that 105 is just somewhere in this quadrant here. So that means it's going to be 180 minus 105, which is 75 degrees. So that's our reference angle. And also, so that's the first thing. You want to do the reference angle. The second thing, as we did with cosine, you want to find the SIGN of this value, and the sine SIGN is, in this case, it's positive. If it was negative, then you would actually, this negative here, this negative right there, that would cancel out. It would be a negative of a negative. Okay, so the sign is positive. So really our new problem is negative sine and 105. Just get your combination, obviously turn to 75 degrees, and that's going to be 30 plus 45 degrees. And we just use that and just keep that negative on the outside. So it's sine of 30, cosine of 45. It's plus, so it's plus here. And it's going to be cosine of 30, sine of 45. And we do all our work. Sine of 30, 1/2, 45, root 2 over 2, plus root 3 over 2, and root 2 over 2. That's equal to negative, so it's square root of 2 plus the square root of 6 over 4. And then no parentheses allowed in your final answer, so you need to simplify that. And it's negative root 2 minus root 6 over 4. And that's your answer for that problem. Okay, so that's how you deal with negatives. That's how you also deal with angles that are not acute. So let's do one more example with sine. If I have the sine of negative 195 degrees. Good problem. Good problem. Okay, so it's got a lot to it. First of all, it's negative sine of 195 degrees. And 195 degrees is in this quadrant here, so it's negative. So the first thing I do is my reference angle is going to be 195 minus 180 equals 15 degrees. And I already determined that it is negative because we're in quadrant 3. So this new problem is now negative, that's that one, and that negative gets carried down to, so it's negative, negative, sine of 15 degrees, which is going to be 45 minus 30. You could also say 60 minus 45, that would give you the exact same answer. So it's really positive sine of 45 minus 30, which is just sine of 45, cosine of 30, and then it's minus, so it's minus here, cosine of 45, sine of 30. So it's going to be root 2 over 2, root 3 over 2, minus root 2 over 2, 1/2. So it's going to be root 6 minus root 2 all over 4. Okay, now one problem where we actually work backwards. If I give you a problem that looks like this, sine of 83 degrees, cosine of 53 degrees, minus cosine of 83 degrees, sine of 53 degrees. You're looking at the problem going, I have no idea what sine of 83 is or cosine of 53. How am I supposed to do this problem? But you should recognize this is a difference, sine difference problem. And basically you're just kind of saying, we learned it as sine of A minus B. And so here it is, sine of A, cosine of B. So this is your A, and this is your B. So really, if I plug it, if I recognize that it is, sine difference, you will now say sine of 83 degrees minus 53 degrees, which is sine of 30 degrees, which is just 1/2. And that's your final answer. So that's actually pretty easy. So let's do one example where I give you some information about cosine of s, cosine of t, or sine of s, sine of t. I tell you the quadrant, and you have to figure out the sum and difference for sine. So for example, if I have cosine of s is equal to 2/5, and s is in quadrant 4, and sine of t is equal to -3/4, and we're in quadrant, or t is in quadrant 3. Okay, the most important thing you have to do, math fans, is you have to draw a picture. You have to. Okay, it's going to be required. So you want to sketch a quick picture here. We're in quadrant 4. And cosine is x over r, so it's 2 and 5 here. And just be careful when you're using Pythagorean theorem. So it's 5 squared minus 2 squared is square root of 21. And don't forget the sine. Sines are huge. If you make a mistake on one triangle with one sine, all your answers, or most of your answers, are going to be wrong. You have to get the sine correct. And then this one, it's in quadrant 3, and it's y over r, so it's -3, 4. Now be careful, this is not a 3, 4, 5 triangle. This is a 3 something 4 triangle. So you have to use Pythagorean theorem, and if you do that, you get 16 minus 9 is 7. So this is negative square root of 7. Watch your signs again. Very, very important. All right, so basically I have cosine of s is 2/5, so I just need to figure out what sine of s is equal to, and that's just going to be y over r, so it's -√21 over 5, and I need to figure out cosine of t, which is going to be x over r, which is -√7 over 4. And then basically what I'm doing is just plugging everything in to the equation. So if I do sine of s plus t, that's going to be sine of s. It's going to be sine of s, which is -√21 over 5. Cosine of t, which is -√7. And then it's plus because it's sine of sum. So that's going to be cosine of s, which is 2/5, and cosine or sine of t, which is -3/4. Okay, notice my denominators. Once again, they're going to be the same. So I have, And I can simplify this a little bit, right? There's 21 over here and a 7, so I know I can pull a 7 out, and it's going to be positive also. So it's going to be 7 root 3 over 20. Be careful with simplifying your radicals. You guys learned this back in the day. And then minus 6 over 20. So my answer is going to be 7 root 3 minus 6 over 20. Okay. Let's do real quickly sine of s minus t. That's actually, everything is the same except for this sign is going to be negative. So it's 7 root 3 over 20. And then it's going to be minus, and it's going to be minus a negative 6 over 20. So it actually turns out to be 7 root 3 plus 6 over 20. And that's the answer to that. So that is sine, sum, and difference. Have a nice day. Bye.